Good evening, students. It is so good to have you in this supplemental review session for the exam. As noted in the syllabus, there will be 3 exams a semester and a final exam. The lowest exam score will be dropped before calculating the total exam score for a total of 600 points. Any time constraint or conflict that is university approved can serve as a basis for rescheduling an exam. Any missed exam is an absence, if not excused, will result in an automatic 0 for the exam. However, this score can serve as the dropped score. So this is what I'm referring to when I say you can drop your lowest grade. The exam will be released on Friday, September 16th, 2022, instead of Wednesday, September 14th, 2022. You have 24 hours to take it. The deadline is final. No exceptions will be made except for reasons approved by the university. The link to respond to the test assignment will close after 24 hours, and the Moodle link will close after 24 hours to upload the hard copy. So keep that in mind. Um, uh, Hopefully, you're able to get all of the tasks done in order to prepare for this exam. Wishing you all the best. So let's begin the review. We will review for exam 1. Let me change the view. Full screen. There we go. So this is a uh, this is a version of the review. We will review for exam 1 on Wednesday. Homework 3 will be due on Sunday. So these are some quick facts we want to just go through. So as I said earlier, homework 3, which would be given on Saturday, September 10th. It'll be given Saturday, September 10th, and it'll be due on Sunday. But let's just review some quick facts. 1. Solids have a definite shape and are not appreciably compressible. So you want to know these facts. These are going to be important for you to know. It's important for you to review the videos on YouTube as well as the notes from the class, the PowerPoint, and the handouts, the packets, especially this review video. Sodium, Na, is the chemical symbol for elemental sodium. 3. If matter is uniform throughout, it cannot be separated into other substances by physical processes, but can be decomposed into other substances by chemical processes. It is called a compound. 4. Symbol for the element potassium is K. Also remember there will be a quiz given on Monday and on Wednesday. 5. The symbol for the element magnesium is Mg. 6. The initial or tentative explanation for some scientific phenomenon or occurrence is called an hypothesis. 7. A concise verbal statement or mathematical equation that summarizes a broad variety of observations and experiences is called a law. 8. A separation process that depends on differing abilities of substances to form gases is called distillation. Let's proceed. The SI unit for mass is kilogram. 10, my apologies if this is not that clear. 10 or 1 degree of temperature. The 1 degree of temperature that's smallest on the Fahrenheit temperature scale. Actually should read a 1 degree of temperature is smallest on the Fahrenheit temperature scale. 11, a common English set of units for expressing velocity is miles per hour. The SI unit for velocity is meter per second. Momentum is defined as the product of mass and velocity. The SI unit for momentum is kilogram meter per second. Also, some review tips. Review homeworks 1 and 2. Review the quizzes I will give you, and review the lecture videos and problem-solving sessions, and you should be fine and set for the exam. Remember, the exam is 50 questions, 55 questions, 50 multiple choice, and 5 short answer. Number 14, the SI unit of temperature is Kelvin. Number 15, the temperature of 25 degrees Celsius is 298 in kelvins. 16, the freezing point of water at 1 atm pressure is 0 degrees. 17, the temperature of 400 K is the same as 261 degrees Fahrenheit. 18. The temperature of 290 K is the same as 63 degrees Fahrenheit. Also, the number 1.00430 has 6 significant figures. Additionally, in the following list, only light is an example of light is not in the following list. Only light is not an example of matter. 54. The law of constant composition applies to compounds, and it says that the composition of a compound is always the same. Moving forward, the quantum mechanical model of the atom is important because it explains how electrons exist in atoms and how those electrons determine the chemical and physical properties of elements. Light is a transverse wave and is a form of EM radiation, electromagnetic radiation. Light travels at 3.00 times 10 to the 8 meters per second. 7.3. The wavelength of the wave is the distance in space between adjacent crests and is measured in units of distance. E equals hc over lambda, where E equals h nu, and nu is c over lambda. 7.5a. The frequency of the light is related to the color. Nu, or V, however you want to say it, is nu, is directly proportional to the energy of the disturbance, and which is related to the color of the light. For one of your homework assignments, there was a question that said to explain each wavelength. You want to know the answers to that very well. For gamma rays, the frequency, the wavelength, and also you want to know it for X-rays, ultraviolet rays, visible light, infrared rays, microwaves, and radio waves. 7.3. The wavelength of the wave is the distance in space between adjacent crests and is measured in units of distance, as I said earlier. The amplitude of the wave is the vertical height of a crest. The more closely spaced the waves, the shorter the wavelength, the more energy there is. The more energy there is. The amplitude of the electric and magnetic fields in light determine the intensity or brightness of the light. The higher the amplitude is, the more energy the wave has. So I just want to give you a quick guide. There'll be 5 types of short answer questions, short answer calculations that I will release to you or give you on the exam. One type of short answer question, so you'll have 50 multiple choice, and they'll primarily be facts and a few calculations. But the calculation questions for the short answer will be in 5 categories. One problem will be on EM radiation, and it'll be a dimensional analysis problem. The other problem will be on the wave nature of matter using de Broglie's equation. The other question will be on atomic spectroscopy. The other question will be on quantum numbers. And then you will have to know how to draw a Young's double slit diagram. So, for example, if you were given a problem where you were given the distance to the sun as 1.496 times 10 to the 8 kilometers, and you're required to find the time for light to travel from the sun to the earth, you'll think through and you'll come up with a conceptual plan. The conceptual plan would be you convert the distance in kilometers, distance in meters to time, and then the solution would be the distance converted to meters, then multiplied by the reciprocal of the speed of light to give you the time. That'll be 499 seconds. So the wave nature of my sample problem would involve, say you were given a mass of 9.109 times 10 to the 31 kilograms. Lambda is 0.2 nanometers. Find the frequency. Conceptual plan would be you take the mass and the wavelength, convert to frequency, using u is equal to Planck's constant h over mass times wavelength. Solution is going to be 6.626 times 10 to the minus 34 kilograms meters squared per second squared over 9.109 times 10 to the minus 31 kilograms times 0.2 nanometers times 1 meter over 1 times 10 to the 9 nanometers. And that is going to give you 3.6 and 10 to the 6 meters per second. The units are correct. The magnitude is large as would be expected from the particle being calculated. here, particle speed being calculated here, and that particle is the electron. Okay, my apologies for if some of these pictures are blurry. So note, on the exam you will be given a spectrum. So this is an example of the atomic spectroscopy problem. For the problem, you'll be required to solve the energy, and you'll be required to know, find the lambda, the wavelength, and you'll also be required to determine which region of the spectrum it is in. So say, for example, you were given a problem that said you started in the second quantized state or second orbital, and the reaction relaxed to the first orbital. And how you would calculate that, you would use Rydberg's equation, in which you input the final and initial quantized states, then you get the energy values, and then you use the energy values. Using E equals AT over lambda, you transpose it so that lambda is the subject, and then you get the wavelength, and you find that that's typically in the UV or ultraviolet range. So for quantum numbers, you want to know your principal quantum number n. You want to know your angular quantum number L. You want to know the magnetic quantum number M sub L. You want to know the spin quantum number M sub S. You want to know the Heisenberg uncertainty principle. You want to know Pauli's exclusion principle. You want to know wave particle duality ideas. And you want to know the photoelectric effect. Note, writing electron configurations will be assessed in exam 2, not exam 1. Also, you want to know how to draw Young's double slit experiment. So that's kind of the review. We'll discuss more review. We'll do more review on Wednesday. On Monday will be regular lecture. Note, you'll have 2 quizzes. You'll have a quiz on Monday and a quiz on Wednesday. All of this is just preparation for the exam so that you are well versed in the calculations and you have a good understanding as to how to proceed with the exam. The quiz will be released on Monday morning, and quiz 2 will be released Monday morning. Quiz 3 will be released Wednesday morning. So hope you're doing well, and hope you do well on the exam.